Welcome back to Sensible Smells. Let's make sure we knows what's going on.
For today, we're going to identify smells and continue the learning from yesterday. Let's continue with our understanding of functional groups and olfaction. Remember from day one that we always waft in order to smell and not overexpose our olfactory system with smells. And as always, follow directions carefully because that's a part of good science. Before starting this lab, make sure you have a rack of 15 small odor units that are labeled from 1 to 15. Always close lids completely before smelling the next odor. If not, odors will mix. Remember to keep this lab properly scientific. You must write your own opinions about the odors independently. To start, I'm going to take you through an example protocol of odor 1 for aldehydes. Smell the labeled odor unit. Each person and each table should smell and write what they think it smells like and where they have smelled it before. Write down your own results. Once you do, you may share out.
Oh, I think it smells like vanilla. Am I right?
Yes, very good. Now take a look at your handout of the structure of each odor and circle what is reoccurring in the molecular structure. Just like you and your family share certain traits in common, aldehydes are families of organic molecules and all share something in common, something called a functional group. A functional group is a set of atoms in a molecule that give the molecule a characteristic set of physical and chemical properties. For this example, it shows that the functional group is a carbon double bonded to an oxygen and single bonded to hydrogen. Each molecular structure is written in shorthand in full atom version.
What is that?
Shorthand version is not labeled with the carbons and hydrogens. Instead, it shows that the carbons are located where the lines meet and the hydrogens are added depending on the number of bonds to carbon. Full atom version shows carbons and hydrogens labeled. Each carbon should be attached to 4 lines, and if not, the correct number of hydrogens should be added. Look here at this comparison.
I see double lines in the hexagon. What does that mean?
This is called the benzene ring. This shows that there are 3 alternating bonds in the hexagon. There are 6 carbons in total with a hydrogen attached to each.
Oh, okay, I get it. What if there are nitrogens and oxygens in the molecular structure? Do I add anything to them?
If there are any nitrogens or oxygens in structures, don't add anything to them, since they are labeled in both shorthand and full atom version. Once you draw both versions, count the number of hydrogens, carbons, oxygens, and nitrogens for both shorthand and full atom version in your handout.
Why is learning about smell so important?
I'm going to show you a video of Dr. Nye, a scientist at UCSD who studies the relationship between bees and smell and how important it is. Here it is.
Bees that have a weaker sense of sound and a weaker vision than we do, they are very important in their biology and would be the equivalent of us not being able to see. It would be as if a bee were not able to smell. It would be a huge impairment.
You should now learn how to continue this procedure of smelling, identifying the functional groups, and writing the unwritten carbons and hydrogens for ester, phenols, alcohols, terpenes, and ketones. Have fun!